Hello, in this lesson we are going to solve this crackmes. So let's open it. So it will run the 64-bit version of the debugger, and my options are as follows. Add 8 zeros and 8 Fs. For the exception, click on save. Now we'll run it. We are at the entry point, run it again, and the program should be showing a prompt. Okay, let's restart and run again, and it should be showing a prompt. So we can enter anything we like, press enter, and it quits. Okay, so this is a 64-bit program, and it's a command line interface, so we need to run it in a command line to see what bad message it shows. So just navigate to the location and run it in a command line. Enter anything, and this is the bad message that you are seeing. So we are going to search for this bad message in the strings. So we rerun it again, and we search for, right click, search for current modules, string references, and we are going to look for this string, GTFO, you lame as hacker. So now just type lame, and we found it. Okay, notice the address is 8-bit because it's a 64-bit program. So right click, follow in this assembler, and now we are going to analyze it. So right click again, select X Analyzer, Analyze Module. So after it's analyzed, you should be able to see a thick black line to group the functions, and this is the start of the function for the bad message. So once we found the start of the function, right click and go to G, or you can just press G, and it will do a graphical analysis and display it. Now here is our bad message, and this is the jump, and this is the test. So if the AL is 0, jump equal to 0, we'll go here, 401665. If the AL is not 0, then it will go here. So we are going to analyze trace AL. Okay, AL should not be 0. Alright, so what we need to do is we first need to find out what is the username. Once we got the username, it will ask you for the password. So first thing is to tackle the username. So in order to find the username, we can put a breakpoint here, right click, breakpoint, and toggle. So you set a breakpoint, and now we can run the program. So when it runs, it will ask for username. Just type anything, press enter, and it should hit our breakpoint. As you can see, it's half black and half red, meaning that the breakpoint has been hit. So now in order to find out what says AL, we need to step into this call and trace it. So to step into this call, you press the step into button or F7. So now you have stepped into it, you need to refresh the screen, right click, sync with origin, or just press S. And so now you're inside the call. And remember, we are tracing AL. So let's look for AL. Alright, so it's over here and here. So we have two outputs, outcomes. This outcome is bad. it sets EX to 0, which means AL will be 0. But this is good. It sets EX to 1, which means AL will be 1. So this is the one we want. But what makes it come here? It is this jump. And this jump is decided by the value in EX. If EX is not equal to 0, then it will go here and sets the 0 to EX. But if EX is equal to 0, then it will go here. If EX is not equal to 0, it will go here, which is bad. If EX is 0, then it will go here, which is good. So, in order to find out what sets EX to 0, we look at the previous call. Now it seems that this call accepts these parameters before it. Remember, in the 64-bit, we don't need to push the parameter to the stack. We can just move the registers and use the registers directly because there is more registers. So in this case here, these are the arguments for this call. And we can see here, it's going to compare this string with this string. So in this string, this is what we input, AAA, over here. And it's going to compare with this string. So that makes this string the username. So we can just right click command, and copy out the username. And paste it in our notepad. Alright, so we got the username. Now we can test our thing. So we are going to restart it and see how it goes. So we're going to run, and now it's going to ask for the username. We paste our username, then we press enter. Now it asks for the password. Okay, so now it's asking for the password. So now we are at a different level. It's asking for the password. That means our username is correct. Yes? Now what happens if we enter the wrong password? It gives the same bad message. Okay, so now we know. We have the correct username but the wrong password, and the wrong password will give you this bad message. Alright, so remember that. So this is the correct username, and if we enter the wrong password, it will give you the lame message. Alright, so now our job is to try to trace the password routine. Alright, so we need to trace this string. So we restart it again, and now we're going to search for the string again, current module, string references, and we are going to search for this string, GTFO, ULMS hacker. So just key in lame again over here, and we found it. So right click, follow in disassembler, right click, you see we found it here. So we analyze again the module. So once we got the module, then we can do graphical analysis once we get the function. So we can see the function has been detected. Go to the top, put your cursor there, press G or right click and select graph. And now let's trace it. So we managed to get the username, and so we come here and jump over here, and it asks us to enter the password. So now we are here, and then we are going to find out the password. In order to get a password, we need to trace all these calls. As you can see over here, there's a jump which goes to the good message or the bad message. So this is the bad message that we have been getting after we enter the wrong password. So we don't want this, we want this. This is probably the good message. You can see you have successfully logged in. So this is the jump, and this jump is dependent upon the value of AL. If AL is 0, that means jump is equal to 0, it will go to 40168, 6A8, which is here. That means AL should not be 0. Okay, so over here, again, AL should not be 0. So how do you know what sets AL to 0? We need to trace this call. So we put a right click here, breakpoint, toggle this call to breakpoint, and now we are ready to run. So we are going to run it, and we will enter our old password, which we managed to crack. Copy this, paste it in here, enter. Now it's asking for password. Press anything, hit enter, and it should have hit our breakpoint. As you can see, it's partially black and partially red. So now over here, we can find out what is the password by stepping into it. So to step into it, you click this button, step into, or press F7. Okay, so now that you've stepped into, you need to refresh. So you right click, sync with origin, and you will see we are inside the function. Remember, we are tracing AL. AL should not be 0. So let's look for AL. AL is set here or here. Again, we see the same thing. Over here is good. It's moving 1 to EX, meaning AL will be 1. This is what we want. Over here is bad. It's moving 0 to EX. That means AL will be 0. So what makes it come here or here? It is this jump. And this jump is dependent on EX. If EX is 0, then if it's not equal to 0, then it will jump. So if it's not equal to 0, it will jump here and show you the bad result, which is setting 0 to EX. EX should be 0. If EX is 0, then it will jump here. Okay, so EX should be 0. So over here, apparently the EX is determined by the call before it. And this call is comparing again two strings. How do I know this? Because in 64-bit systems, 64-bit programs, we don't use push to push the parameter to the stack. We directly use the registers because there are enough registers. No need to use the push. So apparently these two are the parameters for this call, and this call is comparing these two strings. And it's comparing your password, which you entered, AA, with the correct password, which is this. So this is how you fish the password. So you right click here, and then you command so that you can copy out the password. Right click, copy the password, and we can now paste our password in here. So this is the password. Alright, so now we cancel this, and over here we can now rerun the program and test our new username and password. So now we enter our username first. From here, copy, right click, enter. Now copy our password, copy, right click, enter. And we have successfully solved this challenge. So this is how you can use graphical analysis and together with debugging to solve a challenge by fishing out the serial key, by fishing out the username and the password. So making use of the graphical tool to do static analysis together with debugging is really a great help, as you can easily see the graphical representation of the code. And as you can see here, cracking 64-bit program is no different from cracking 32-bit program. It's the same technique. The only difference is the registers names are prefixed with R instead of E. That's all. That's the only difference. And then the other difference is the parameters are using registers rather than push to stack, as I've explained earlier. So okay, so that's all for this video lesson. Thank you for watching. See you in the next one.